Welcome to this presentation on the C operators. For our programs to perform meaningful work, they have to be able to do arithmetic operations. Sometimes they need to be able to do low-level bitwise operations. They need to be able to do mathematics in particular. And in this lesson, we're going to take a look at the operators C uses for arithmetic, subtraction, multiplication, division. We'll take a look at bitwise operators that allow us to go down and get to the lowest ones and zeros. You need to remember C was written as a programming language for the Unix operating system, and it needed to be able to access data at the bit level, and C provides several operators that allow us to do that. We'll take a look at those. Then we'll learn about operator precedence, and that's the rules that C applies to say, do I do multiplication before I do addition? Because depending on which one it does first, our results can vary substantially, and we'll get to see that. And we'll see how we can control which operators C performs first by grouping things into parentheses. And that's how we'll make sure that we always get the correct result and a consistent result. So let's go ahead and get started. So in the simplest sense, C provides the plus operator for addition, the minus operator for subtraction, the asterisk for multiplication, and the slash for division. And so these are the kind of basic math operators. We'll see that there's other operators that we can use in our programs, but if you know these four, you're off to a good start. And so let's take a look at a program that uses it. In this case, we've got a program that's going to calculate the y value based on a slope and an intercept. And so we've got our include standard.io.h because we need to have printf defined. We've got our int main void, that hasn't changed any from our last lesson. But now we're declaring a couple of variables. We've got a variable named y, which is going to be ultimately the value we want to calculate. We've got a variable named slope. We've got an intercept value. And then we've got the value of x. And you'll remember the equation that y equals mx plus b, or slope times x plus the intercept. And so you can see that we're initializing the slope variable to 3. We have an assignment operator, it's the equal sign, that's one of the C operators. We're initializing the intercept to 2, and we're initializing the variable x to 4. Once we've done that, we can calculate the slope, well, the y equals mx, so we're taking the slope times x, then we're adding to it the intercept, and we're printing out the final result. And so for this particular equation, the y value would be 14. And so use the y equals mx plus b just because it gave us the chance to do multiplication and addition. If you take a look at that second line where it says y equals slope times x plus intercept, if they do the operations from right to left, that works. We take mx plus b, but if we were to do them in the opposite order, we'd get the wrong result. And so in this case, C, as we'll learn, has an operator precedence. It will do multiplication operations that appear in the same line before it will do addition. It will do division before it does addition. Same thing with subtraction. It will do addition and subtraction from left to right, but it would do a multiplication in this case first before it adds that intercept value. We'll drill down a little bit deeper into operator precedence in a few minutes, but let's take a look at another example. In this case, we've got a program that's going to tell us the number of seconds in a day and the number of hours in a day. And we start out with a long variable, and it's long because it's storing a big value, which is the number of seconds in a day. Well, let's take a look at our math. There's 60 seconds in a minute, there's 60 minutes in an hour, there's 24 hours in a day, so 60 times 24, yep, that gets us our seconds in a day. Then we want to know the hours in a day, and that's going to be this number of seconds in a day divided by 60 seconds in an hour, 60 minutes or in a minute, 60 minutes in an hour. So sure enough, we get the correct answers for both. Note that we're dealing with a variable type int and a variable type long. So within our printf statement, we print the long variable using the %LD specifier, and we print the int variable using the %D specifier. This program illustrates the use of the C modulo operator. The modulo operator is confusing at first until somebody explains to you that that stands for the remainder operator. So we're going to perform a division and we're going to get some value plus a remainder. And so in this case, we've got two variables being defined, result and remainder. And so we do an integer division of 7 divided by 2. And we assign the result to the result variable, and then we calculate the remainder. To get the remainder of an integer division, use the modulo operator, the percent sign. So 7 mod 2 in this case is 3 remainder 1, and that's sure enough, that's the output we get. We'll revisit the modulo operator later when we start to determine if a value is even or odd, and we'll have code that you can use to do that kind of determination. But don't let the name be confusing. It's just really the remainder operator. A common operation that you'll perform in your programs is to add 1 to a variable's value. You might do it to move through the values in an array. You might do it to count the number of lines in a file. You may do it to repeat a statement a specific number of times, but adding 1 or incrementing a variable's value is a common operation. So to help us do that, C provides an increment operator. It's kind of a shorthand notation. So rather than saying variable equals variable plus 1, we can just simply use the increment operator and say variable plus plus. And that's the same as saying variable, add 1 to the variable. We can put the plus plus at the start of the variable and at the end of the variable. And if we're not doing an assignment of the variable's value, then they're both the same. They're both just incrementing the variable's value. If we're doing an assignment operation, then we need to make a determination of, do we want to use the variable's value prior to incrementing it, and then we'd put the plus plus at the end, or do we want to increment the variable's value before assigning it? And so let's take a look at a couple examples here. In our first program code, we've got include standard io.h, that's fine. We've got int main void, that's fine. Now we're declaring two variables. A variable named a that we initialize to the value 0. We're then using a comma operator because we're declaring another value of type int. We're not initializing it, we're just naming it b. And then we're saying that b is replaced by the value of a++. Well, we know that a++ means increment the variable a by 1. But we said we can put that plus plus before a, or we can put it after the a, prefix or postfix. When we use an assignment and we're incrementing that variable, if we put it afterwards, as we've done here, it's going to first assign the value of a to b in this case. Once that assignment's done, it's then going to increment a by 1. So when we run this program, we looked at and see that a ends with the value 1. That makes sense because we incremented it. But b has the value 0. That's because a started out with the value 0. We assigned that value, and then we incremented the value of a. Let's look at a second example, and hopefully things will become a little clearer. In this case, same scenario. Two integer variables, one named a, initialized to 0, one named b. In this case, we're assigning b the value of plus a. That says increment a and then assign it. So if we increment a goes from 0 to 1, so we assign it. So b gets the value 1 and a has the value 1. So when we print them out, sure enough, we see a is 1 and b is 1. And so what's your takeaway? The plus plus operator increments a variable's value. When we're doing an assignment statement, we have to make a decision as do we want to first use the variable's value in an increment, or do we want to increment and then use the variable's value? And that will tell you whether or not you put the plus plus before the variable or after the variable name. We'll take a look at this again as we look at the decrement operator. And so just as it's common to increment a variable's value by 1, it's also common to decrement a variable's value by 1. And to help us do that, C provides the decrement operator, which is the double minus signs. And so the variable minus minus is the same as saying variable is replaced by variable minus 1. And again, the decrement operator can be used as a prefix operator before the variable name or a postfix after the variable name. And it only becomes critical when we're using the variable in an assignment. So again, let's take a look at our examples. In this case, a equals 0. So we've declared a variable called a, and we've declared a variable called b. And our statement says b is replaced by, or b is assigned, the value in a, which is currently 0. So b will be assigned 0. Then it says decrement a. So a should have the value -1. And sure enough, when we run our printf statements, that's what we see. A is equal to -1 and b is equal to 0. That's because we use the postfix, which says use the variable's value, then decrement the variable. In contrast, this program uses the prefix operator. So again, we've got the same variables, a and b, initialize a to 0, and we're saying assign the variable b the value of a first decremented. So a becomes 0 minus 1 is -1, and that's the value that we assign to b, and sure enough, when we print them, that's what we see. So where are we going with this? Let's do a couple things that are fun, and just jumping ahead a little bit in your learning. But we said that a common operation is to do an increment of variable. So in this case, we've got a variable of type char. It's a letter, and we're going to use a for loop. A for loop allows us to repeat a set of statements until a specific condition is met. So we're going to, and we'll talk about the for loop in great detail in our chapter or our class on iterative processing. And so we say letters equal to a. That's our first assignment. And as long as letter is less than z, we want you to output that character using putchar, and then come up and increment letter so it points to the next one. And so when we run this little loop is going to end up displaying the letters A, B, C, D, E, F, G, the entire alphabet. And when we get to letter having the value z, the loop will end and the program will end. And so this is just a kind of a real-world use of the increment operator. In a similar way, this program, and again, it's a little more advanced than where we're at, but it's kind of fun, creates a variable called count. And then we have a while loop, which is going to repeat the statement as long as count is greater than or equal to 0. So we're going to count down from 100 to 0. Once count's less than 0, the loop will end and the program will end. But you can see within the loop, we display the value and then we decrement it using the postfix decrement operator. And so we'll do a lot more of this, particularly when we start working with character strings and working with values that are at memory addresses, so we can do some math on the memory address to compare the value in one memory location to another. So we're going to see a lot of increment and decrement operators, and so you should just practice with them, play with them on these programs a little bit until you start getting comfortable. So depending on your program's purpose, there may need to be times when you need to get down in the weeds and look at a value in terms of its bits. And it's not that common, but C provides the capability. C was written for an operating system, and operating systems have to look at the bits sometimes. And so C provides a bitwise OR operation. And if you've never done binary math, this might be a little bit new, but I'm showing you the result of the value 2 is represented in binary as a series of zeros and then a final 1 and a 0. The value 5 is represented in binary as a 1, 0, 1. And when we do a bitwise OR, our result becomes a 1 if either of the bits that we're ORing are 1. And so if they're a 1 and a 0 gives us a 1, a 0 and a 1 gives us a 1, a 1 and a 1 gives us a 1. And so the value 2 with a bitwise OR of the value 5 is going to produce 7. And so let's see how we do that. The bitwise OR operator in C is the pipe symbol that you'd use for IO redirection from the command line. And so we've got a variable called A that we assign the value to. We've got a variable called B, just like our math example. And then we print the bitwise OR result is A or bitwise OR with B and 7. And sure enough, that shows up with what our math showed. Just as C provides a bitwise OR operation, it also provides a bitwise AND operation. And the bitwise AND, both values being ANDed have to be 1 for the result to be 1. If either is a 0, then the result's going to be 0. So a bitwise AND of the values 5 and 2, there's no place in that comparison where we have a 1 being ANDed with a 1. And so our bitwise result ends up yielding the value 0. And sure enough, in our program, we assign A the value 2, B the value 5. We perform a bitwise AND, which is the single ampersand character. We use the ampersand again when we start looking at decision making and if statements, but that will be the double ampersand for a logical AND as opposed to the single ampersand, which is a bitwise AND. But our program results match our math, so I'm happy. Finally, the bitwise exclusive OR, when you do the math, if either one is 1, then we're going to get a result as 1, but if both the variables that we're comparing, both the bits, are 1, we're going to get a 0. That's how it differs from the OR. And so it's only when both values are 1 does it behave differently than an OR operation. And so in this case, the very first rightmost 0 and 1 produce a result of 1. Then we have a 1 and a 1. That's the rule of the bitwise exclusive OR, that becomes 0. And then a 1 and a 0 yield a 1. So again, our same, or a different series of numbers, I guess in this case we've got A equals 2, B equals 7, and we do an exclusive OR of it, and we get the result 5, which matches our math. So we've looked at the C's increment and decrement operators. Another shorthand notation that C provides is to take an expression like A equals A plus 5 and make it simplified by A plus equal 5. That would mean the same thing. A multiplication equals 2 would mean A equals A times 2. And this is just a shorthand notation to save us a little bit of typing. And so it's interesting, when I first did this, I said, why wouldn't you just write it out? But once you get used to it and saving the time, you just assume that a C programmer should be able to read this syntax and figure it out. And so I think when you're first getting started, saying A equals A plus 5 makes a lot of sense, very readable. But as you start getting more advanced, A plus equal 5, you know what it does, and so it's shorter to type. You'll get more respect from C programmers, so your best practice kind of becomes using this shorthand notation. Let's look at our example. We've got a variable A of type int that we initialize to 5. Then we do A plus equal 5. So that's saying, take the value that's in A, 5, and add to it 5, so A should initially have the value 10. Then we're doing A star equal 2. Well, the asterisk is the multiplication operator, so they take the value in A and multiply it by 2 and assign it back to A. And so A currently has value 10, multiplied by 2 is 20, assign it, and our printf statement sure enough prints A has a value 20. So our math worked out. You'll see the shorthand notation in a lot of C programs that you look at, so start getting used to it. In another lesson, we'll look at C's if-else processing, which allows our programs to perform decision making. And C provides what's called a conditional operator, which is very similar to an if statement, but it's a single line operator. And the format of it is some expression, a question mark, a value that gets assigned if the result of the expression was true, followed by a colon, and a value that gets assigned if the result of the expression was false. And so let's see how we use it. We've got two variables. One's called A, it's got the value 1. B, one's called B, it's got the value 2. And we want to assign the minimum of those two values to the variable called min. So we've got our condition. Is A less than B? If that's a true statement, A is the minimum. So our syntax says question mark A, assign A if the condition is true, otherwise assign B. And so with this single statement, we can process it. And you can kind of look at this right now and say, if we wanted to create one that returns the max, we just change that first greater than or less than symbol to a greater than symbol, and we have something almost immediately. But you'll see the use of the condition operator. It'll take you a little while to get used to, but it is kind of a nice shorthand notation. But it's equivalent to doing an if-else statement that's shown right at the top of the page. In other lessons, we're going to learn how to allocate memory dynamically. We might create a memory buffer that we use for a character array. We may create a linked list, a doubly linked list, or even a binary tree. And when we do that, we'll allocate memory based on the size of the variables that we're trying to store. And so we need to know the number of bytes that each variable uses. And C provides a size of operator to which you can pass a data type. So you can see in our program here, we're passing it the size of int, the size of float, the size of double, and the size of char. We can also pass it a variable, and we use the variables type to determine the size of the item, and it always returns the size in terms of the number of bytes required to store a value of that type in memory. So you can see that the size of an int is 4 bytes. The size of a float is 4 bytes. Double is double that, so the size of a double is 8 bytes. To store an ASCII character requires 1 byte, and so our program is just using the size of operator. What you need to note is in the printf statement, you can see that we're using the specifier %LD for a long value. Size of returns a long after it calculates the amount of memory required. So we talked a little bit about C's bitwise AND, bitwise OR, bitwise exclusive OR operators. In addition, when you're performing low-level bitwise operations, you can do a shift. It's important to note that it's a shift and not a rotate, meaning we don't circle the values as they're being shifted, they rotate out and get filled back in with a 0. And so we have a left shift operator, which is going to make a value typically larger because we're shifting it into different binary positions. And then we have a right shift operator as well. Our first program declares variables A, B, and C as unsigned ints and assigns each of them the value 1. And then we see the impact of shifting the variable A 1 position, 1-bit position, B 2-bit position, C 3-bit positions. And sure enough, if you write out the binary, shifting a binary 1 position gives a binary 2. Shifting a binary 2 1 position gives us a binary 4. Shifting a binary 4 gives us an 8, and so on. And then the second program is doing the same operation, shifting in the opposite direction. So we start out with A, B, and C being equal to 16, a larger value, because when we do the right shift, we're actually making the value smaller. And so shifting it once makes a 16 an 8. Shifting a 16 twice makes it a 4, and shifting it 3 times makes it a 2. So our math is working and aligns with our output. You won't see bit shift operations that often, but if you do see the double greater than or double less than symbols, that's the operation C is performing. And we've touched on the fact that C has a set of rules or precedents that specify which operations it performs first. It's going to perform multiplication before it performs division. It's going to perform division before it performs subtraction. And so there's a precedence table that we'll show here in a minute. But if you don't understand the precedence, you run the risk of getting the wrong result based on your arithmetic operations. And so in the first program, you can see that we have a variable called result. We're passing it assigning it the value 1 plus 2 times 3. So we would think 1 plus 2 is 3 times 3 is 9. But when we run the program, we see that the result is 7. And that's because C's operator precedent says do the multiplication before you do the addition. And so 3 times 2 is 6 plus 1 is 7. That's how C's getting that result. If we need to force a program to execute arithmetic expression in a specific precedence, we can do that by grouping the things we want to have calculated first within parentheses. So here we have the same expression, but we've grouped the 1 plus 2 in parentheses. C will always perform what's in parentheses first. So we get 1 plus 2 is 3 times 3 gives us a result of 9. So what you need to remember about the precedence is when in doubt, group them in parentheses. But here's our operator precedence table from high to low. So you can see that those parentheses rank high on the list, and then followed by our unary increment operators and things, followed by there's multiplication, division, and modulo, and right below it's addition and subtraction. So C is always going to perform multiplication, division, modulo math before it would do addition or subtraction. C would do addition or subtraction before it would do a bitwise shift. And so you can see how the items that appear on the same row within the precedence table, C will perform those from left to right as they appear in the expression. But it's the ones that are above each other that you need to be aware of and sometimes do your grouping within parentheses to force the result that you need. And so far, all the programs that we've created have been sequential in nature, meaning they start at the first statement in the program, they do the second, they do the third, all the way to the last statement in the program, and then they end. For programs to perform really meaningful work, the programs must be able to make decisions, such as today's Sunday, turn on football. If the person's 21 years old, take them to Las Vegas. If they're younger than 21, take them to Disney World. And so our programs start to do decision making. In the next lesson, we're going to take a look at C's conditional operators, the if statement, the if-else statement, the switch statement, that allow our programs to make decisions. And at that point in time, we can really start building some intelligence into our applications. So look forward to that, and I will see you there.